Hi, welcome class. So my name is Prem Asim Jain and we are going to start ninth session of this training. So before we start, we'll go through the sorted algorithm, which was so Java has provided us some methods which are part of collections class, and it has method which allow us to do sorting of the Java collection, whosoever inherited from the collection interface and the APIs. So whosoever who follows that interface, the collection framework provides the reverse sort and lot many other features. But the homework or the activity is to do the sorting algorithm without using the out of the box provided third party methods from Java. So this one is the implementation by Naren. So Naren, have you tried this and it works for you? Everything?
Yeah, yes, sir. It's working fine.
Okay. So what you did, would you like to explain what steps you have taken here?
Yeah, sir. Like initially, I had created an object that is array list, and using add method, some indexes. I have added approximately 5 to 6 integers there.
Hmm.
So after that, in order to if you are seeing line number 30, 31, 32, 33, I have used an enhanced for loop to iterate over an array list, but I commented that out because I don't need that.
Mm-hmm. Okay.
And after that, I have used a for loop wherein I initialized an integer, and it will loop until till it is the loop reaches the size of an array.
Mm-hmm.
Like again, I have a for loop.
Mm-hmm.
Like there, like again, this loop too will increments. What can I say? Like till the size of array list, and after that, like if you are seeing line number 42, I wrote there an if condition. So like I'm comparing the two consecutive numbers there, like
Mm-hmm.
j comparing integer with j minus 1th index and jth index elements,
Mm-hmm.
and if this condition satisfies, the numbers will get swapped. Like that, all the numbers in array will be sorted, like will be swapped, so that the array will be in sorted order.
Okay, awesome. So the question is, was there any need basically to do the sorting, full sorting basically? Can we just remove and reduce the number also? So what
What do you
happens?
mean?
So what does it mean that in the first time the sorting will so cyclometric is if this is 10 and then 10 cross 10 it would be 100, but
Yes.
in the first pass we call it as pass each iteration, the whatever is the heaviest number it will travel down at the bottom. So in the next iteration, if even we do one iteration less, then it would be optimized. So we don't have to do 10 cross 10. The number of iteration might be less. So we'll just try to see that. First I'll run. This is what I fixed here. So this is nothing else, but we just needed to change the condition here. So this one was the heaviest number, it traveled down over here, and whatever was the lightest number, it traveled up. So this way, this thing worked. Now, as a matter of fact, whatever the number we are trying to iterate, basically, can they be reduced? That is the question in each time whenever it is happening. So if that can be reduced and results are same, so we can achieve probably the same result in less iterations. So this is saying index array. Okay. Okay, awesome. So we are now able to get the same result, but number of iteration are less. So we will just try to prove whatever we are trying to achieve. So this makes little bit of difference in thinking between a good programmer and a normal programmer. So normal programmer will achieve the result, but a good programmer will achieve the result with high performance and less resource hogging. So here, look, okay, let me prove this, then we will discuss. So I want to make integer integer as count, which should be 0. Fine. And then whenever we are doing the sorting here, let's try to do a sort. And just for consistency, we'll cup 5 number 1, 2, 3, 4, 5. Let's take 10. 5, 6, 7, 8, 9, and 10. So we have 10 numbers. Each time whenever it goes inside this loop, this number will get increased. And by the end, we will say system.out.println total iteration, and we will print the count. Let's try to do this. So total iteration is just 24 in this way. Now we will pick up Naren's loop and we'll also test it. So let us try to comment this stuff out, and let's try to pick this stuff in. There are some plus, but we can ignore that. So another way to ignore this is there is something which is called as raw. So this is a good opportunity to teach you something else. So if you have to take some code just for trying out from GitHub, even from my file, my repository, so you can go something like this. So this way you will not get line numbers or plus or whatever. This is called as raw. So just take the raw, it would help. So let's go and try to figure this out. You have a dot list, so we can rename our list as a. This is super simple. You go to refactor and rename just to save some time and nothing else. And then you have a temp. We also have a temp, but you have a int and we have an integer. So what do? We make yours int temp. Oh, you defined it inside. That is fine. Actually, it is not required inside. What it is saying. Okay, this is because of the name clashes. So we will remove this clash. Now it's compiling fine. So let's try to run and then let's try to count. And then we will print the count by the end. So the count is supposed to run here. So more or less, just a moment. More or less this is the same count which is going. But the size you are taking here and here. So this multiply by this number of A. So this is the same number. I think then we are good. And what we did here is we reduced the count each time. Okay, let me try something else. We are having I from I to 10. So outer loop would go 10 times and inner loop has to technically go 10 times again. So 10 cross 10 has to be 100. Okay, because this is inside if probably. Let's go here. Do it here. Oops. Sorry. So we will do count here, then it will show us probably something related to 99 or 100. Okay, so this is 90. So that is fine. So we have got lot many iterations because when we are doing the cyclometric complexity of outer multiply by inner. But in this case, now let's try to roll it back. So we got the numbers from this. Now we'll try to get number from here also, from this as well. So we will comment this. Now we will uncomment this. Uncomment, uncomment, and we need temp. So we have temp and everything is here. Let's try to reduce this. Okay, so this is less count. So now that is valid. So what has happened that if you go to inside this, whatever the swapping, it is having same number of iterations in this and this. But once we come up here, we got almost 50% efficiency, because in this loop we were achieving the same result, but for achieving same result the iterations were 90, but in this we have saved the iteration. So what we are doing over here is j is increasing every time. So we are trying to reduce it from each number. So if this is 10, we have got 40, like some improvement here. If we make the number more exponential complexity, let's say this is 10,000 time, the list is let's say 250 elements. So 250 cross 250 would be way too much in this loop, but here we might get some improvement. And why is this happening? That a dot size is will always remain constant. So this cross this is more. But in this case, the size, whatever we are trying to subtract it more. So first time, let's say this is 10. So first time minus 1, when we say minus 1, this might run first for 9 times. Then j will become 1, and then 2, then 3. Whatever number you add, you subtract, and you will loop it lesser and lesser. So that is how we gain the performance improvement with these such kind of loops or whatever. But the result would remain same. So achieving the same result, but try to saving iteration and whatever gives you the performance benefit and edge. So the people, my friend, who they used to do VLSI programming in the chip, so they used to fight for nanosecond and microsecond, because even tiny of the tiny second matters. And even one, if you can reduce even one iteration, that helps, because this for loop might run so many times. So even if you one time save one iteration, it keeps value. Here we were able to get 50% better performance. So that is fine. So Naren, please update this, and then run it one time lesser, whatever your I is, something like that. You can tweak it. So for now, since it is good, and thanks for completing this, I am going to merge your homework. Let me see. There are no. I will just leave a comment and then I'll merge. So this is called a cyclometric complexity. If there are 3 for loop, then it's a more trouble. 10 into 10 into 10,000. So even then, if you save even the single or two, it makes a lot of performance improvement. So that is called a cyclometric complexity. If interview someone says, you know what is cyclometric complexity, because it cycles around whatever looping and looping inside. Please try to reduce the number of iterations by, yeah, now you already know. I'm giving a single line comment. Spurti and Mohan, have you guys tried this thing?
Yes, sir, I tried it, but forgot to push now. Now, now I'm doing it.
Okay.
Hello?
Yeah, no, okay, that is fine. So push it in your folder, because then like whenever we'll do the submission, we will have everything over there inside your box. So now plan is we will like by the end of this Java lectures, around 14 whatever, we have to submit a project which will be the library management system. So it will again have sorting, and that sorting we will do our own sorting algorithm. We will try not to leverage on ready-made features, because in interview they'll make you sit, they'll give you simple these cyclomat some example or puzzle. If you are able to solve, you are in, and that happens always. It's not for the first job. I have around 12 to 15 year of experience, and still sometimes they give us these tests anytime, and we have to solve it. We struggle around, but then we solve, we figure out the way. So better we are trained, better it is. And Spurti, what about you?
Sir, I have tried it, sir, but I've stuck up in a point. I would push it by tomorrow.
Okay, that is fine. So, Harsha, okay, just a moment. Sorry about this. Oops, where is the link? I think this is the link. So now we will go with the questions from you guys, and I think Harsha, uh, Bragdish. Hello, Bragdish. Are you able to hear me? Can you please introduce yourself? I hope you are able to listen, but you are on mute. Okay, that's good. I just want to, get introduction, and then I'll continue. Mute, send unmute request. Connect audio, unmute request. So there is some control from where you might have to unmute. Okay, no problem. Okay, now we'll give, so I'll just give you a couple of minutes to ask you a question, and then we'll start, because I have to finish everything and we have to understand these interfaces. Naren, please shoot questions if you have. Okay, so let me get started. So we will make a collection package. Now inside collection package, we will go one by one, and then we will implement all the data types. I will let you know the nitty-gritty of that, some of their basic functionality, how they work and why they get used. So once you will get familiarized, then you have to apply them all in your own branch. That is your homework that you will learn now. You will see everything how it works, and then hands on you have to practically apply them. So what are we taking first? Framework. So I'll not repeat this lecture again, but this is again a short introduction that there are some interfaces which are extended or implemented by other concrete classes, and these concrete classes are our data structure, which means they hold the data for us. So essentially, there are two to three ways of data structures which are used in general. One is map; its hierarchy is little bit different. One is list, and one is set. So list is just like the array. Array is you have to predefine it, and array list is dynamic. So as soon as you want to add, it will add whatever you want to add. It's dynamic. It does not have length. Sat is similar to list, but sat is a duplicate remover, which means it keeps only the unique values. So these are the most two common stuff which gets used. And another thing is map. So we'll see about map bit later, and I'll also let you know its implementation. So if we go with the array list class hierarchy is here. So you have array list, and then there are some methods which is implemented inside this. And this is a abstract. This is one more class intermediately, but then now iterable is something. So whatever class which implements iterable, it will support your enhanced for loop. What Naren has tried, like the enhanced for loop. We'll also see here in hands-on coding. I'll take your focus on that. What is normal for loop and what is enhanced for loop. Only thing in enhanced for loop usually is you don't get the index, or you don't need it basically. It runs all your own. So repetitive for I is equal to blah less than blah blah. Those conditions are not required by doing enhanced for loop and iterable interfaces. So this we already have ran our array list examples in the sorting also, and this is what is called as the generic or the data type. It could be integer, string, float, or whatever, but whatever you give, then that is only accepted. So you cannot add oranges and apples together. If you say it is apple, then everything which you are trying to add in this basket has to be an apple and not orange. Two ways to iterate over element: by iterator framework and by for loop. So this will be your uh, enhanced for loop. We can quickly run this. The class names are weird, but that's fine. My array list. Why I'm doing it my array list? Because there is a class, already existing class, with the name array list. So we will call it as my array list. We will just rename this class. We will delete it. Everything good. So this is enhanced for loop, wherein this one is your collection name, and this one is the intermediate object reference. We'll run it. So you call it as obj. You can also call it as Superman. That is fine. This will run the same way. So this is intermediate variable. You can do anything with this. But what you cannot give here is something like, if you want to tell it as default, then it would give you an error. Default one is fine. So there are some reserved keywords. Here is an interview question. What are reserved keywords in any programming language? It's not Java specific. So reserved keywords are those which cannot be used as identifier. Identifier is what? So our Superman was the identifier here. This Superman, right? So you can name something, alias something, or name something with any of the identifier by which you will identify it. But if it's a keyword, let's say class, import, whatever, void, so you cannot even give the name for the identifier which is reserved, which is part of the reserved keyword. So all document specification, they publish what are their keywords, reserved keywords, and that cannot be. Okay, enough of this. So we understood enhanced for loop. Now let's try to understand what is iterable, and then we will understand. So user defined class objects in Java in array list. So they are just giving the example that instead of adding the string, you can make a custom class and add it. We will quickly run through this also. This entire stuff is not required. We'll just go from here to here inside our PSVM. So this is our PSVM. PSVM is short form for public static void main. Now just remember one interesting thing before we move ahead is these brackets, or we called it as block. So if it is a single line statement, then you don't need these brackets. This is common sense that if you don't have any brackets, you will not get any compilation error and it will go fine. That's not a problem. Let's get rid of this and then let's try to understand our student. Now why it is giving trouble? There are some imports missing and then it is also missing the student. So we need to get the student class, which is here. Now another concept here is in a Java program, you can have one public class and then you can have any class, basically private class or whatever. So you can make it as a public class and then you can make as this a normal class. So here all these compilation error went away. Now I told you last time that it is always a good practice that you have to program against an interface, not against a class. So here today it's array list, you can make it as linked list or whatever. If here it is list, then object can get changed. Once you will learn Spring, there is a concept called as dependency injection, in which you don't have to create the concrete class, it will be injected directly by the framework. And that time if you change the concrete class anytime, that is fine, you don't have to make all changes, but you have to abide by an interface. So we will just have one interface. We'll also see this in hands-on in some time. So let's fix this. How to fix it? There is some shortcut key. What is it saying? Control enter, command enter. Okay, okay. So please observe here. The as soon as I provided the dependency, it needs iterator. So it was giving me trouble. Stupid ID. No, I mean not stupid ID, stupid me. But that's why I have to type it. Sometime it doesn't understand whatever we want to say to it. So what is happening over here is we have quickly created three objects. So this is our class which is having some properties, and the constructor is picking up all these values which are required or essential for the student. We have got bunch of items here and then we just added it. So the deal here is if this would have been a string, then you cannot add anything. So this is called as generic. Now wherever you hear the word generic, you can just relate it. That generic means it's a strict type of bondage for any collection or class, and templates, that is very high level templates and all. Probably we might learn or we don't have to learn it right away, but in terms of your collection or other stuff, whenever generic means it's type bonded, strongly type bonded, so only that thing can enter. However, if you don't give it this, sometimes repetition helps you to get the concept way deep inside your brain. Now you can edit anything in this. Even I can add a number. So I will add a 0 and it will take happily, which we don't want, because at runtime it becomes confusing. It's not the consistent behavior. That is why people don't allow anything to go in from the initial design itself. Now let's go to iterable. So what iterable does? Iterable, so anything which is having in parent the iterator interface, it will have the iterable interface, it will have the iterator method. So this gives this the pointer. Now this is kind of a pointer which points to the next element. So this is student, it has 1 2 3, it does not have 4. So firstly, whenever by default the pointer would be initially at the 0th, and then it says, oh, does it have any next element? If it has, it will print it, and then the pointer will be moved to something else. That's how it works. We'll just run it. So same result, but the way to achieve is different. Implementation is different, but same results. So try not to get in this complexity. Try always to use enhanced for loops in your programming or whenever you do, in your assignments and everywhere. So add all is simple, straightforward. We'll skip this. And these are other examples. What is this example is saying? Let's see an array list example where we are adding books to list and printing all books. Nothing else. They just have listed the books and they are trying to do the system.out.println. So let's try to go another stuff. This is linked list. So it will also have the iterable. It is also allowing the collection. So it would have the default sorting and all the stuff. Now doubly linked list, we were maybe couple of days back we were saying that it will have its value and the address of the next element. But doubly linked list will know what is in my front and back. Both ways it is connected. And why you don't use linked list and why you use array list, there are some features. So if you have to do lot of deletions, then this guy can directly point to something else in term. But in linked list, whenever you are trying to, sorry, in array list, whenever you are trying to delete some element, technically it deletes or it scraps or garbage collects the entire array list and creates a new one from scratch. So this is very deep concept. You might do Google or books and you might not get it that simply or straightforward. So I'll just again repeat it and let you know what happens. So there is a for loop which we were running in our example. Let's say this. So whenever you are trying to create another list, you are trying to delete these three elements. So what this guy will do, it will run this, and whenever it matches these three condition, it will delete those values, and whatever are the remaining values, it will create another list, something like this. So it will create another list. It will add everything from A into the B, whatever are the elements. Then it will delete this from memory itself, and at the end it will say A assign is equal to B. So whatever are the values which was there in B, so this would be the short version. Let's say if we deleted this much, I'm just giving you an example. So all these values, first it will create a temp list, and then it scraps everything in memory, and then this object reference would be assigned a new list at some location which would be B. But this is fast. It has index 0 1 2 3 whatever. For the link, this is array list. I have to just imagine that this is the array list. So array list, it needs duplication, but in linked list it does not need duplication. It will just change the in memory pointer then and there itself. Linked list also,
Sir,
yeah.
sir, I just have a doubt because uh, as in Java, we don't use pointers. Pointers are not supported by Java.
Hmm.
How is a linked list and doubly linked list actually implemented or accessed through?
Okay, so there is something which is called as hash code. So internal, so there are two ways. Pointer. So let's try to understand the concept of what pointer is. So pointer is pointing to a memory location, which can be accessed by the user directly. So there are two ways you can go to that memory location, and then whatever is the value you can access it. When user can do it from C or Go language, that is called the pointer, and you also get the value. But Java uses the same thing. He does not allow the user because of some confusion, or it has its own mechanism of garbage collection. So something which you are holding the user defined pointer memory address, it might get be cleaned up by Java. That's why it does not allow you. So the hash code, what let's try to print a default hash code for student. So you will see that is actually pointing to the memory address in the heap, that location. We can just uh, print for this student itself. System dot out dot print s1 dot hash code. So you see something here, this guy. Let me do ln. So this guy is the hash code. Basically, this is the pointing, this is the pointer or pointing to this location. So you are able to see this, but you don't have the control to manually go and fetch values or anything from Java. But in Go language or in C, C++, wherever, you have that capability to access that memory location directly. Here you have object references, which gets managed directly by the uh, mm, they have GC called as garbage collector. So today, let's say the S1 is pointing to this location. Maybe after some time, when cleanup happens, this is the entire chunk, and it has 5 objects lying here and there. So Java will clean this entire chunk for a bigger memory location, and it can internally move it and put it somewhere else. So that way the internal location of the memory keeps on changing, and Java does not allow pointers because it is garbage collected. And you can always change this. So the default implementation of hash code will provide you this mm, whatever is called the memory address, but you have the capability to override. And okay, let's try to override. O capital hash code. Let me get the hash code signature. So whenever you are trying to overwrite anything, the signature has to be same. Fine. Now what will happen is, so here is the deal. Now if you previously, if you will iterate on S1, S2, S3, everything will get different hash code. Let's try to do that. But now everyone will get the same hash code because we have overridden it. So they are pointing to some locations. They are trying to generate their hash code, and then they are trying to print it. Maybe it could be sitting on the same chunk, or whatever the memory address for that. We are trying to write it for, we have to say st, because they were pointing to the same. So I was also surprised. Now it technically it has to give different, because it's not a list, it's an object, so they have to have different memory pointers, memory locations. Yeah, there you go. Fine. So this is these are all three different objects, and they are all sitting on different location, and whatever is the location they are sitting, the address, that is called as the hash code, which is pointing by default. Now you can change you can change its implementation. So you are trying to override from the basic object. You are saying, okay, hash code. Now everything will give you the same answer, 420, but it does not mean that it is sitting there. So it will sit wherever Java wants, and Java will do the memory management on its own. It does not allow user to tweak around it that. But there are some cases wherein you can change the hash code implementation. So we will learn this on the weekend class, wherein I'll let you know how hash table or hash set works for faster retrieval, and there is some concept, and we have to override that hash code method, and why we need to override, how it makes the search and iteration faster, and everything we will cover that. So doubly linked list, same thing, you will not find even a minute difference externally, in terms of the calls and everything, because they are all following the same contract of iterable and collection. In underlying thing might get changed. So try this on your own, so we can cover more in this lecture. And for each class, whatever you try, make a separate class. Let's say here, let's say Naren or whatever, Mohan or Spurti or Brajraj. I don't know if he knows Git or not. So he has to learn, or I'll talk to him later on after the class when everybody leaves. So what you guys need to do is make a package called as collection, then make the class, and inside the class do the hands-on implementation of everything. Because right now you are learning Java, after a week you will learn Mongo and something else, and then in the brain it does not stays more longer until and unless you practice it with your own hands. If you practice, it will stick for longer. You will forget, probably might forget it, but it will stick longer, and then the recovery will be faster next time whenever you need it, when you will be doing actual programming in the office somewhere sitting. Otherwise it's just like a theory, you learn it, you hear it, you enjoy it, and then you forget it. It's like TV serial or a movie. So now we'll go to next. This is, they're talking about the list interface, list declaration, list iterator, same thing. You're trying to do a iterable, you will get the object, you will check its next element, and then keep on printing next value. You can always iterate in a previous order. That means you can go back, loop back. Now let's come to set. So set, public class, hash set. Hash set, what is hashing? Hash means hash code and bucketing. I'll let you know. Then there is something called as serializable and clonable. So clonable is a very good concept. Clone means exact replica copy of an object can be created by using clone instead of calling a new constructor or something like that. Serializable uses specially for video games or something. You are playing a video game and then you want to continue in some later point. So there is an option called as save. You can save the state of whatever your player state was, or you're doing a car game. So your car was about to finish. No, car is a bad example. Your player. So player had a life, 30% life. It had some weapons or something. So once you serialize it, whatever is the state of that object in the game, they will put it inside a text file, and then they will put the text file inside your in the memory of the game. As soon as you restart and resume, it would again read the exact state of your layer, let's say the life was 80%, then it will retrieve and make it the object again. So you can start your video game exactly at the same point. That is how the practical usage of serializable. We will do the hands-on also, and then you will be able to connect it better. Hash that has same endpoints. You connect, you create it the same way, you add stuff the same way, you iterate it with the same way. It's just that it's a duplicate remover. We already tried it in the last class. I'll just run it once so that the new guy, he was not there in the last class, so he can see that. Let's make it first. Why does it say? Okay, good. So we have Ajay, Vijay, Ravi. Let's try to run this. Compilation error. Something duplicated. Okay. Now this will give problem. Let's comment it out. So set is something which always supports unique value. So many times I repeat it that it will just, you will, it will go inside your brain, and whenever someone says, okay, what is set? So without thinking, you will just say, okay, set is a duplicate remover. It only holds the unique value. That's all. It is similar to the list. So you don't get the duplicate values. It removes it. However, if you have a list, it will keep whatever number of items you want to keep. This is hash set. Now linked hash set. So linked, there is underlying some differences. So please go to the theory and read it. So Java linked hash set class is a hash table and linked list implementation of the set interface. So set is an interface. It inherits hash set class and implements set interface. The important point about Java linked hash set classes are contains unique elements only like hashset, provides all operational set operations, and permit all null elements, maintain insertion order. So what is the benefit here is whatever the way you are trying to insert the values, you will retrieve it in the same order, seems like. So we can check this. So you have Ajay, Ajay, Vijay, Vijay. This is also giving it in the same order though. And this will also give it in the same order. Okay. Compilation error. Iterator 1. Traversing element. Still there is some error. So to figure out the error, usually, you don't have to scroll. You see this red guy here. So it tells you where the problem is. It might need one more bracket or it might need one less bracket. Whatever. So it's simple to fix. Now you see everything, I hope, is good, but we'll run and then we'll see. Yeah, so we ran it and it same output, same thing, little bit different implementation. So there is also called that as a tree set. So they have different implementation. In oh they it just came. I named it and it came. So what it does it maintains the ascending order. So I think it will do the sorting all by itself. So we can see that how it does the sorting by itself. This is why this is this is the implementation. Now let's Ajay should come first and Vijay should come last. What have I missed? One more bracket. Look, Ajay came first. So the other guy linked or whatever the normal hash set, whatever, they will keep the order of insertion. But the tree set, what it does, no matter whatever order you are inserting, but it will have the sorted. Uh, if it's a string, it will be A to Z. If it's a number, it will sort it in the number. So in the sorting algorithm, if you want, you can keep it in this way. We can try it real quick. I and T E G E are integer, and then you have integer. Here also you should have integer. This is fine. Now you will do al dot add. First we will add 100. Then we'll say al dot add. We will add, so it would be sorted. Sorted means smaller. So let's try smaller number. I'll just add 3. And then this would be more smaller. And then we'll run it. So it got automatically sorted. Internally it will run all those for loop, nested for loop, of cyclomatic complexity optimized in some or the other way, which we tried, but it keeps the stuff in sorted way. Please remember this, it's important stuff for tree set. Now there is queue interface implemented. The priority queue class provides the facility of using queue, but it does not orders the element in first out manner. It inherits abstract queue class. This is usually never, very rarely people use it or never use it basically. But they have few things called as peak to remove some element from whatever is at the end. So this can be used whenever you just need to remove the last element. Somewhere in some of the data structure probably you might use it, but usually no one uses it. People goes basically with the array list, and then they pick their own value, whatever they need to remove. Based on that they will remove, or based on index. I can run it, that's not a problem. It also have a remove. It will also have the head peak queue element, whatever. Let's try to run this. Because in JavaScript you have a pop, there is a method which is called as pop, will override everything. So here we are trying to have a priority queue. Why is it not liking? Practically in my 15 years I haven't used it, because the kind of apps I built, we don't have the need for these. So what we did is it's the same stuff. You do a add, you have added stuff left and right. We'll just try one more thing. So we started with Rahul. Then we were trying to print whatever is the element at the top basically. Rerun it. Add is Amit. Iterating through elements. So it went with Amit, Jai, Rahul. Seems like it sorted it. Priority queue. Okay. See if it says if it gets sorted. It does not order the element in, first out. So Spurti was saying queue is first in, first out, but priority queue seems like contradicting its own way. So you are not having the first in, first out. We have first in was Rahul, but then when they printed it, they sorted it in some other stuff. And then after removing elements, so what they have tried here is they have they printed this, then they printed this, and then they removed something, and then there was a poll. Poll, what's the return type for poll? Poll, yeah,
Pool returns the bottom element. I think so.
it returns the element. Removes all the element from the priority queue. This is clear. So Java docs guys have not provided much description of this here. Technically they should, and whatever are the important classes like array list or whatever, you will find proper description of some multi-line description. But okay, let's not worry much about it. So it would do some of the, but this is very, this gets never asked or used. So do not invest much more time on this, but just go through basic API endpoints for the normal queue. That can help. So this one is the normal queue. A normal queue, you are having this in some series. Does it say FIFO here? This is the priority queue implementation. So seems like queue is the interface wherein this is the implementation. Java queue is the interface. Orders the element in first out manner. In FIFO, first element is removed first and last element is removed last. This is how the interface speaks about itself. Now there are priority queue classes. The priority queue class provides the facility of using queue, but it does not order the element in first out. It inherits abstract queue class. Okay, that is fine. Then let's move to map interface. This I am not sure, DQs or whatever. Personally, I have no hands-on on this or I never use it. So what I usually use it is a map. So let's try to cover that first. So what happens technically, the arrays, they are also kind of map. Map has a key and a value. Key could be your index, which would be 0, 1 or whatever, and value could be anything. We put the student's object inside the list whatever we created. So those different objects. Now in map there is some different way or better way of storing the values. So what happens if let's say you have the account number or token number or something. So they might want to use something on your account. So imagine it's a bank. So they say account dot put wherever, and then they'll put the account number and whatever money you give to them, it can get added or whatever. And when they have to retrieve it something, then they can retrieve it easily by using account number or something. It can be any key, it can be string also. So let's try to first run this simple one, and then I'll tell you the permutation combination of the. Technically this can go in PSVM. So this time it is right. Map is the interface, and then hash map or is the implementation. And the integer can be the key and string can be the value. If we take the student example, student can be the value, whatever object type you are trying to define. So this integer is the key, it is 100. If you will try to insert some string, it would not like it. So you are trying to store these value, and then they have different methods to iterate. So you say am dot entry set. Entry set means this becomes a set. So this also is a duplicate remover. You cannot add two values with the same account number. If I will say a scene, and then we'll run this. Okay, so it has removed this. What does that mean? That if you have whatever the values, the last value would be taken up in the key, and that is what it will override. If you try to duplicate, it will override its previous stuff. So you have in the map you have integer as the key and string as the value. You can also make it as string versus string, and these values can go as string, and then it would start liking it. Now let us try to see one phenomenon. So the string duplicate string, it has overridden this value. So how we need to iterate it? We are doing a enhanced for loop. Now inside this enhanced for loop, we are calling map.entry_set. So this set will have typically whatever the value, the keys basically. Now you say map, whatever is the map dot entry as m, and then you are trying to do a m dot get value. So whatever is the value, this the short form for this whatever obj. So key and value will be written in this way: key and the value. This is the key, and this is the value. So this is sometime used very oftenly. And please remember that there you have a add, you have a add, but here you have a put. So they call it as put. Now you can only get the set also. If you have to, let's say you have bank accounts and the value. Now you need to understand how many bank accounts you have, whatever these values. So you can just call this method map.entry_set, and then it will give you a set, and you can only iterate over the values of this set. We can try this. traversing it. So what we are trying to do here is, and I hope you guys also know debugging, right? It got stuck or hanged. Let's wait for some time. It got hanged. I just wanted to start it in the debug mode so that I can show you guys few options, but it got hanged. No worries, on weekends lecture we'll just go through the debugging, watch and all that, whatever the options are there. Even in Mac things hang, which is strange. Windows hangs a lot, but Mac is supposed to be a good stuff. This laptop is $2,000, $2,000 laptop, and still it behaves just like a Windows $500 laptop. Okay, my idea is not coming up. So guys, if you have any question, let's try to discuss that, and we will cover our comparable and comparator interface on the Sunday's lecture at the beginning of that. So there is very little remaining. We have already covered so far all the data types, and we are doing map, but now my IntelliJ is not opening up. It got crashed. Let me give it a last attempt. No, it's not coming up. Fine. So I think this is the end of the session for today. Now I'll send you the video recording link for this, and then I will also send you the homework which you're supposed to do, and I will give you a brief introduction about comparable and comparator, so that you guys can try on your own, and once we will start our class I will let you know, or we'll do hands-on. So comparable and comparator interface works in such a way that you have to do the so collection provides you some way to sort. You saw that TreeSet has done the automatic sorting, and when it does the automatic sorting, it has some parameters. If it's a number, it understands. If it's a string, it understands. But if it is a student, how it would understand? In number, it is 0 to 10 or whatever, increasing or decreasing order. But in student, it has no means to figure out which student is increasing order or decreasing order. In student, you might have a roll number. So probably it could be from roll number way, or it could be the name. So name would be from alphabetically from Asim to Zinat Aman or something like that, A to Z. But we have to somehow tell the machine that how we are going to compare that parameter. So we yesterday lecture we just saw the equals method. Inside the equals method you can define on what basis you have to do it. Have you guys tried out that equals method the other day which I pushed?
Yes, Ji.
Okay, great. So here we tried we you can give some comparison, something like that. So we will now go with the comparable comparator, and then I'll make you understand that. Enum is also pretty much similar. Let's continue with this. My idea has opened up. So map is similar. We'll go next. Java hash map. Hash map also have same thing, same method, no changes the way you are using. Some minute changes inside the inner implementation. To remove, they have exposed a method called as remove, and whenever you will give it the key, it will remove those values from here. Difference between hash set and hash map. Hash set contains only values, whereas hash map contains entry key and the value. So you can make here in the book, for book example, this might come handy probably. So you have books. So this is the book. Where is the book? Yeah. So first argument. Now whenever we say, this is a parameterized function or parameterized method or a constructor, parameterized constructor, and you are trying to pass the argument. So first argument would be the ID, second would be the name, third is author, and fourth is publisher and quantity. So you are trying to put it in some sequence in order or index, whatever you're trying to adding, and you're traversing it here. No big deal. What they have showed over in this example is in the map, instead of putting key and value as string, they are just doing a custom type, that integer and the object type book. That's all what they did. Linked hash map, same to same stuff. You will get some benefits. In what case? So it is linked. When it is linked, the retrieval and modification is easier. That is the only benefit which you get when you use this implementation versus the other implementation. And one more benefit is you may have one null key and multiple null values. It is same as hash map. Instead maintains insertion order. So there are two benefits. Since it's linked, so first element, second, they are connected. It know the link. So the order will be maintained in the insertion order. First stuff. Second stuff is you can always have a null key. So since it's an important point, I'll just run this for you. Now let's try to save it with a null value. So this allowed you one null value and one null key and null value. And again we try null. So these guys will allow you one null key, because if you have two keys and even if you have values, it will override that stuff. So you have one null. for this. Now linked hash map. Yeah, we already have gone through it. Let's try to move to comparable and comparative fast. Tree map will do the sorting on some or the other way. Now tree map takes one interface which is called as comparator. Let's try to go with the definition first. So, and this is important. All other stuff was not that important, Q and all that, but this is super important. So, Java tree map class implements the map interface by using a tree. It provides an efficient means of storing key value pairs in sorted order. Sorted order means we will let it know on what basis it needs to sort. That's what we are going to learn. The important point about Java tree map class are the tree map contains value based on the key. It implements the navigable map interface and extends abstract map class. It contains only unique elements. It cannot have a null key but can have multiple null values. So if you are using tree map, we will try the same thing and null might not be allowed here. What was allowed in this case in the hash map. So tree map class declaration. This is the tree map. You define it, the key and the value. It extends this, it implements this, and then it also implements serializable and clonable. So serializable is a markup interface. It does not have any method. Just open the serializable interface and you will not find any method. Once we'll do the lecture, I'll let you know what is markup interface. It's a common interview question. Method of Java tree map classes. So this is what you get in the map. If it contains some key, if it contains some value, so it will give you true or false in return. Then you can get the first key, and then you can get whatever object. If you pass a key, it will give you the value. It gives you the whatever the last key, since it's sorting it, right? And you can remove any element by the key. You can put all. If you have some map, you can just pass entire map and then it will put all. Entry set means whatever are the number of keys, corresponding keys, you will get the entry set. Then the size, array list dot size, similarly you get the size, and it also gives you whatever are the just the values. So you get the entry set and then you can also get the values over here. So we are trying to see the example here of a tree map. This one is a tree map. So tree map has to technically do the sorting for us. So let's try this guy. Let me make my tree map collection. Okay. So what I want to prove here is the insertion order previously was different. So we had 100 and whatever. Now the insertion order has been changed. Even though the insertion order has been changed, but it is doing the sorting. So it will do sorting on what? The values or the key. So there is a common sense, no brainer. It has to be the key. Whatever is the key, it will do the default sorting on them. So it's a number. Even if it is string, it will make it alphabetical. And that's how it goes. This you get the entry set over here, and then based on whatever you get the entry set, you can get the value, and that's how you're printing here. There is a remove example. You can pass a key and remove it. Let's see that as well. So we are trying to remove something from tree map 102. 102 has been removed. What about if you pass some incorrect value? What will happen? Any guesses? It will not remove anything because it will try to find that value. If it doesn't find, it cannot remove. So all whatever was there, that will be printed. Everything got printed. It couldn't find that key. Tree map, same thing. They are just trying to do example, the generic example for the book. Now hash table, Java hash table class. The hash table class implements a hash table. Let's try to put null. The class very specifically said that this does not allow you a null. If you try to null, you will get the runtime error. There are two kind of error: compilation time and runtime. So it got compiled, it didn't had any problem because null by default you can assign it to anything. So it took it. But when you try to run it, it was because when it will try to sort on what basis where it will put null. Is it the first thing? Is it the last thing? It gets confused. That is why it says that java.util.tree map, you get a null pointer exception. The algorithm tries to sort it in some or the other way. But since this is not a real value, it is a null, then you get a null pointer exception. Once you give it a proper value, it runs and sorts it properly, takes it up. So that's the most important point. Cannot have a null key. Remove also works same, everything same. Let's go next. Difference between hash map and hash table. So please remember this: hash map is not synchronized, hash table is synchronized. It is thread safe. So rest all points are pretty much easy. You guys can understand all by yourself. This is something which I need to make you understand. So there is in threading there is something which is called as synchronization. Synchronization means same method or block of code can be accessed by multiple threads. Imagine the example of you're doing shopping use in the Amazon, and then two guys are trying to purchase something. So two users at the same time might iterate over the same list of items. So if it is non-synchronized, which means if it is just a hash map kind of stuff, then there is a possibility that at the same point concurrent user, two processes or two user are trying to access the same. So as long as they access or read, it is not a problem. But when they try to write, or when once they try to deposit money in the bank, and if they are not synchronized and two threads invoked at the same time, so there might be some issues that it might deposit double money or less money or incorrect behavior. That is why they have something called a synchronized block. So one method can only access it at a time. It is more safe. It is thread safe. So in multi-threading, we'll learn more about it. But that's the only main difference. Rest all is almost very similar or not that useful. So there is something called as enum set. So what enum means is there are some set of values which are required. So we'll just go with this example and this will make you understand faster. So there could be values which can be unlimited. Let's say number, it can be from 0 to million or whatever. but there is some fixed set of items which you expect to be inserted, we make as part of enum. Let's say there could be only 7 days. So far there is no eighth day. Nothing comes after Sunday. Like Monday will come, whatever. Apart from these 7 days. So that's how you define the enum as days. So any one value will come inside it, and so you have to have just one value for that. Let's try to access next example. Okay, this is more nice example. Let's try to run this. So enum is kind of a class in itself. We'll just go. Enum might be confusing, but let's see how it behaves. Okay, so you have enum map. Enum map has a day and the string. This is a map. Now inside the day, this is what could be the probable values. If you try to do anything else, it would give you an error. Let's say if I have to say Shanivar, this is a string, it won't allow you. So first thing is you have to use the enum which is called as day, and then it has only these options, whatever you are giving here. Apart from it, you cannot enter anything else. So whenever you want the user to pick the option from the restriction, you use enum. The best example, you go to McDonald's and then you have three options: small burger, medium burger, or big burger. You don't have another option. So if you are trying to create some project wherein you have fixed set of input which is required, then you would have to use the enum. So I think this should be enough for today, and then we'll have 2 hours lecture on Saturday and Sunday from 10 to 12. So we will cover next things and next items over there, because comparable and comparator will take some time, and I have a call from my India team. It's already 9. I have some bunch of developers, 4 5 developers working for me from there. So I'll drop you a mail, and now it's a hard stop for me, so I'm dropping off. Thanks, guys.